Hello there, and welcome to The Sleepy Scientist. Tonight we leave behind the familiar glow of stars and planets and drift gently into the quiet spaces between them, where the universe feels softer, wider, and unhurried. Our focus rests on space clouds, vast regions of gas and dust suspended in deep space, moving so slowly that change itself seems to relax in their presence. Before we begin, allow your body to settle naturally. Let your shoulders loosen without effort, and let your jaw rest gently. There is no need to control your breathing. Simply allow it to find a calm rhythm on its own. Whatever thoughts followed you here can remain in the distance, becoming quieter as your attention drifts outward. Space clouds exist in places where silence feels complete. They float far from noise, far from urgency, and far from anything that demands attention. In these regions, time stretches, motion softens, and even light behaves patiently, taking years to pass through layers of drifting gas and dust. As we move slowly through this calm science, we will explore how space clouds form, how they endure for millions of years, and how they quietly shape the universe without haste. These facts are not meant to impress or awaken curiosity sharply. They are meant to move gently, to steady the mind, and to let awareness soften as the universe reveals itself at its own pace. If you find comfort in these quiet journeys through science, you're always welcome to subscribe and return whenever you need calm, curiosity, or rest. For now, there is nothing you need to remember and nothing you need to imagine perfectly. Just listen and allow the quiet nature of space clouds to guide your thoughts into a slower, more peaceful state. Let's begin. Space clouds are vast regions of gas and dust that drift through the space between stars, existing in such low density that their particles can travel long distances without ever meeting another. Even though these clouds can span hundreds of light years, the matter within them moves so gently that their overall shape can remain almost unchanged for millions of years. Most space clouds are composed mainly of hydrogen, the simplest element in the universe, quietly accompanied by helium and small traces of heavier elements created inside long-gone stars. These atoms float freely, separated by enormous distances, creating an environment where emptiness feels more present than substance. Temperatures inside space. Clouds are extremely low, often only a few degrees above absolute zero, where heat has nearly disappeared. In this deep cold, atoms slow their motion, allowing fragile molecules to form and survive without being broken apart by energetic collisions. Tiny dust grains drift throughout space clouds, each one smaller than a grain of sand and often no larger than particles of smoke. These grains absorb passing starlight and release energy slowly, helping maintain the cloud's calm thermal balance over vast stretches of time. Some space clouds appear dark when they gently block the light from stars behind them, creating soft silhouettes against brighter regions of the galaxy. These dark clouds are not empty, but rich with material quietly waiting undisturbed for the slow processes of gravity to act. Other space clouds glow faintly when nearby stars emit radiation that energizes their gas. When atoms release this energy, they emit soft, diffuse light that spreads evenly through the cloud, creating gentle colors without sharp edges or sudden brightness. The shapes of space clouds are shaped gradually by gravity, radiation, and faint shock waves passing through space. Over immense timescales, these influences stretch the clouds into long filaments or compress them into rounded forms, all without urgency or force. Magnetic fields pass quietly through space clouds, subtly guiding the movement of charged particles and influencing how gas and dust align. These fields are weak yet persistent, helping shape the internal structure of clouds with steady patience. Within denser regions of space clouds, gravity slowly gathers material inward, increasing pressure so gradually that change is almost imperceptible. These regions can remain calm and stable for millions of years before any visible transformation begins. Space clouds contain a surprising variety of molecules, including water vapor, carbon monoxide, and simple organic compounds. These molecules form slowly on the surfaces of dust grains, assembling atom by atom in an environment where time moves gently and nothing rushes their creation. Space clouds often exist as part of much larger structures known as molecular clouds, which can contain enough material to form thousands of stars over very long periods of time. These immense clouds drift through galaxies like slow-moving continents, their boundaries defined not by solid edges, but by gradual changes in density and temperature. Within space clouds, motion is dominated by turbulence that is incredibly gentle compared to anything experienced on Earth. Gas flows at speeds so low that they would feel like complete stillness, allowing the cloud to maintain a calm internal rhythm rather than chaotic movement. Light travels differently through space clouds, as dust grains scatter and absorb photons, softening their paths and dimming their brightness. This process allows clouds to create sheltered regions within themselves, where radiation is reduced and temperatures remain low and stable. Some space clouds are the remnants of ancient stars that have shed their outer layers near the end of their lives. These expanding clouds drift outwards slowly, carrying elements formed deep inside stellar cores and distributing them gently into the surrounding galaxy. The chemistry inside space clouds unfolds at an unhurried pace, with reactions that may take thousands or even millions of years to complete. In the cold, thin environment, molecules form and persist without disruption, creating a quiet laboratory for complex chemistry. Space clouds often contain icy coatings on their dust grains, formed when gases freeze onto their surfaces in the deep cold. These icy layers provide places where atoms can meet and bond, allowing more complex molecules to develop slowly over time. Gravity inside a space cloud is extremely weak, yet over vast timescales it becomes a guiding influence. Its steady pull encourages material to drift inward, shaping the cloud gradually without sudden collapse or violent motion. As space clouds move through galaxies, they respond gently to the gravitational influence of spiral arms and nearby star clusters. These interactions subtly compress and stretch the clouds, guiding their evolution without disrupting their overall calm. Radiation from nearby stars can slowly erode the edges of space clouds, causing gas to drift away over time. This process happens gently, allowing clouds to thin and fade without dramatic endings. Even as parts of a space cloud change, much of it can remain unchanged for tens of millions of years. In this way, space clouds serve as some of the most patient structures in the universe, quietly existing while stars are born, evolve, and fade around them. Space clouds provide the raw material from which new stars eventually emerge, yet this transformation happens so slowly that the clouds remain calm for most of their existence. Long before a star begins to shine, the cloud rests in a balanced state, gently holding its gas and dust in place. In the densest regions of space clouds, particles are still separated by vast distances, allowing matter to gather without friction or heat. This quiet accumulation creates environments where gravity works patiently, guiding material inward without disturbance. Some space clouds are so large that different regions within them can exist under very different conditions at the same time. While one area remains cold and dark, another may be softly illuminated by nearby starlight, each part coexisting without conflict. The presence of dust in space clouds helps regulate temperature by blocking harsh radiation and allowing heat to escape slowly. This balance keeps the cloud stable, preventing sudden changes that could disrupt its long-term calm. Space clouds often drift through the thin gas of the interstellar medium, interacting gently with their surroundings. These interactions create subtle boundaries where densities change gradually rather than abruptly. Within space clouds, sound cannot travel as it does on Earth, as the gas is far too thin to carry pressure waves efficiently. This creates an environment of profound silence, where even energetic events unfold without audible disturbance. The colours we observe in space clouds depend on the specific atoms and molecules present and how they interact with light. These colours are not signs of activity, but of calm atomic processes releasing energy in steady, predictable ways. Some space clouds exist high above the plane of their galaxies, drifting in regions where stars are sparse and motion is minimal. These clouds experience even greater isolation, existing in near total quiet for extended periods. Space clouds can slowly rotate, though their rotation is so gentle that it takes millions of years to complete a single turn. This slow movement adds a subtle sense of balance to their long-lived structure. Even when stars begin forming within a space cloud, much of the surrounding material remains undisturbed. The cloud continues its quiet existence, absorbing change without losing its overall calm. Space clouds can remain suspended in a delicate balance for millions of years, held steady between the inward pull of gravity and the outward pressure created by temperature and motion. This balance allows them to exist without rushing toward collapse or dispersal, maintaining a quiet stability that defines much of their lifespan. Within space clouds, gravity does not act suddenly or forcefully, but as a gentle invitation for particles to drift closer together. Over immense periods of time, this slow attraction subtly reshapes the cloud without disturbing its calm nature. Some space clouds are so diffuse that light from distant stars passes through them almost unchanged, revealing only the faintest hints of their presence. These nearly invisible clouds remind us that much of the universe exists quietly, without announcing itself. As space clouds travel through a galaxy, they follow broad orbital paths shaped by the galaxy's overall mass. Their movement is smooth and unhurried, guided by gravity on scales so large that individual motion feels almost meaningless. The internal pressure of a space cloud is extremely low, far lower than any vacuum created on Earth. This allows gas and dust to drift freely, responding slowly to even the faintest forces acting upon them. Cosmic rays, which are high-energy particles moving through the galaxy, pass through space clouds without causing disruption. Their interactions are rare and gentle, leaving the overall structure of the cloud unchanged. Space clouds often form layered structures, with denser cores surrounded by more diffuse outer regions. These layers develop gradually, creating smooth transitions rather than sharp boundaries. The dust within space clouds helps shield their interiors from harsh ultraviolet radiation. This protection allows fragile molecules to survive deep within the cloud, preserved in darkness and cold. Some space clouds are enriched with elements like carbon, oxygen, and nitrogen, all created in earlier generations of stars. These elements drift quietly within the cloud, becoming part of the material that shapes future cosmic systems. Even when influenced by nearby stars or galactic motion, space clouds respond slowly, adjusting their shape over long periods rather than reacting abruptly. This gradual response preserves the calm, steady nature that defines their existence. Space clouds often exist in a state of near-perfect patience, where gas and dust remain suspended without urgency, neither collapsing rapidly nor dispersing into emptiness. This balance is maintained by a quiet interplay between gravity, temperature, and motion, allowing the cloud to hold its form for tens of millions of years while the universe slowly evolves around it. Within a space cloud, gravity works not as a force of sudden change, but as a subtle, constant presence that gently encourages particles to drift closer together. This inward pull is so weak that it may take millions of years for even the smallest increase in density to become noticeable, giving the cloud its characteristic sense of calm persistence. Some regions of space clouds are so diffuse that their presence can only be detected through the faint absorption of background starlight. These nearly invisible clouds exist quietly in the galaxy, revealing themselves only through careful observation, reminding us that much of the universe unfolds beyond direct perception. As space clouds orbit within their galaxies, they follow smooth, graceful paths shaped by the collective mass of stars, gas, and dark matter. Their motion is slow and steady, taking hundreds of millions of years to complete a single galactic circuit, creating a feeling of timeless drift rather than travel. The internal pressure within a space cloud is far lower than anything experienced on Earth, even in the emptiest laboratory vacuums. In this environment, particles move freely with minimal resistance, responding gently to faint forces that guide their long-term evolution without causing disruption. High-energy particles, known as cosmic rays, pass quietly through space clouds, occasionally interacting with atoms but rarely altering the cloud's overall structure. These encounters are brief and subtle, leaving the cloud's calm state largely unchanged as it continues its slow journey through space. Space clouds often develop layered interiors, with denser regions gradually forming toward their centers and more diffuse material surrounding them. These layers emerge slowly over time, creating smooth transitions that reflect the cloud's gradual response to gravity and temperature, rather than any abrupt event. Dust grains within space. Clouds play a protective role by absorbing harsh radiation from nearby stars, allowing the interior of the cloud to remain cool and stable. This shielding creates safe, dark environments where delicate molecules can exist for long periods without being broken apart. Many space clouds contain elements such as carbon, oxygen, and nitrogen, which were created inside earlier generations of stars and released gently into space. These elements drift quietly within the cloud, becoming part of the material that will shape future stars, planets, and systems yet to form. Even when nearby stars influence a space cloud through radiation or gravitational pull, the cloud responds gradually, adjusting its shape over immense timescales. This slow adaptation preserves the cloud's overall tranquility, allowing it to remain a steady presence within the dynamic environment of the galaxy. Space clouds often exist in a condition where time feels almost suspended, because the physical processes within them occur so slowly that meaningful change requires millions of years. Atoms drift, molecules form, and structures subtly adjust at a pace that far exceeds human lifetimes, creating an environment where patience is not just present, but fundamental. Within the calm interior of a space cloud, energy is distributed evenly and gently, preventing sudden fluctuations in temperature or pressure. This quiet balance allows the cloud to remain stable for vast stretches of cosmic history, holding its form even as stars nearby are born, shine, and fade away. The motion of gas inside a space cloud is influenced by extremely soft turbulence, more like a slow swirl than a current. These motions are so gentle that they rarely disturb the overall structure of the cloud, instead contributing to its long-term evolution in a smooth, continuous way. Space clouds can slowly change their chemical composition over time, as atoms and molecules interact at very low temperatures. These interactions are rare and unhurried, allowing complex compounds to exist for long periods without being broken apart by heat or radiation. Light entering a space cloud does not travel in a straight, uninterrupted path, but is scattered and absorbed by dust grains along the way. This soft interaction dims and diffuses the light, creating shaded regions where darkness feels deep and consistent rather than abrupt. Some space clouds exist in relative isolation, far from regions of active star formation or intense radiation. In these quiet areas of galaxies, clouds can persist almost unchanged, experiencing minimal external influence and maintaining a near-constant internal state. The boundaries of space clouds are not sharply defined, but fade gradually into surrounding space as density decreases. This gentle transition creates an impression of softness, where the cloud blends seamlessly into the interstellar medium rather than ending suddenly. As space clouds slowly evolve, they may fragment into smaller regions, each following its own quiet path through time. This fragmentation does not happen suddenly, but unfolds gradually as gravity and motion subtly reshape the cloud's interior. The cold environment within space clouds allows atoms to remain loosely bound, making the clouds responsive to even the faintest forces. This sensitivity contributes to their slow adaptability, allowing them to change shape without losing their overall calm. Despite their vast size, space clouds exert very little influence on their surroundings at any given moment. Their presence is subtle rather than commanding, shaping the galaxy quietly over long timescales rather than through dramatic events. Space clouds often act as quiet reservoirs of matter, holding gas and dust in a stable state for millions of years before any noticeable transformation begins. During this long period of stillness, the cloud exists without urgency, simply maintaining its presence as the galaxy moves gently around it. Inside a space cloud, the balance between gravity and internal pressure is delicate and enduring. Neither force dominates quickly, allowing the cloud to remain suspended in a calm equilibrium where change is possible but never rushed. The particles within a space cloud move independently, each following its own slow path through space. Because collisions are rare, these motions remain smooth and uninterrupted, contributing to the overall sense of quiet that defines the cloud's interior. Over time, space clouds can gradually cool even further as energy escapes in faint radiation. This slow loss of energy deepens the cloud's stillness, making its interior an even more stable environment for long-term processes to unfold. Some space clouds are influenced by the gentle passage of spiral density waves within galaxies. These waves compress the clouds slightly as they pass, encouraging subtle internal changes without disrupting the cloud's overall calm structure. The interaction between gas and dust within space clouds creates a natural filtering effect, where certain wavelengths of light are absorbed while others pass through. This selective interaction shapes how the cloud is perceived from a distance, often giving it a soft, muted appearance. Space clouds can persist through multiple generations of stars, existing before stars form and remaining long after those stars have completed their life cycles. This continuity allows clouds to act as long-term participants in the evolving story of the galaxy. Within the quiet depths of space clouds, chemical reactions proceed at extremely slow rates, guided by chance encounters between atoms and molecules. These reactions do not seek completion, but simply occur when conditions allow, contributing gently to the cloud's complexity. The mass of a space cloud is often spread unevenly, with subtle variations in density creating regions of slightly different behavior. These variations develop gradually, allowing the cloud to remain cohesive while still accommodating internal diversity. Even when external forces influence a space cloud, such as radiation from distant stars, the response remains measured and gradual. The cloud absorbs and adjusts to these influences without losing its overall sense of calm continuity. Space clouds often exist in regions where gravity from nearby objects is spread so evenly that no single direction dominates their motion. This balanced gravitational environment allows the cloud to drift calmly through space, maintaining its shape without being pulled abruptly toward any one source. The gas within space clouds is mostly transparent, yet its sheer scale means that even faint interactions accumulate over time. Light passing through these regions is gradually softened, creating subtle variations in brightness that reflect the cloud's quiet internal structure. Many space clouds contain areas where dust grains cluster slightly more densely, forming calm pockets that feel sheltered from external influence. These regions remain stable for long periods, protected from harsh radiation and sudden change. Space clouds respond slowly to changes in their surroundings, often continuing along their existing paths even as nearby stars move or fade away. This persistence gives them a sense of continuity, as though they are gently out of step with the faster rhythms of stellar life. The slow movement of matter within space clouds allows them to retain memories of past events, such as ancient shock waves or distant stellar activity. These influences are preserved not as sharp disruptions, but as gentle patterns embedded within the cloud structure. In the quiet interiors of space clouds, molecules can remain intact for extraordinarily long periods of time. The absence of heat and frequent collisions allows these molecules to drift peacefully, maintaining their form without pressure to change. Space clouds occupy regions far above or below the main disk of their galaxy, where matter is sparse and motion is minimal. In these locations, clouds experience even deeper stillness, existing almost entirely removed from energetic galactic processes. The overall shape of a space cloud may appear irregular, yet it reflects a balance of countless small influences acting over time. This irregularity is not chaotic, but a natural result of gentle forces working together without urgency. Space clouds often act as buffers within galaxies, absorbing energy and redistributing matter slowly. By doing so, they help maintain the long-term stability of their surroundings without drawing attention to their role. Even as the universe continues to expand, space clouds remain locally calm, their internal motions unaffected by the vast scale of cosmic change. Within them, the sense of stillness persists, independent of the larger motion of space itself. Space clouds often remain gently unchanged even as the larger galaxy around them evolves, rotates, and reshapes itself over hundreds of millions of years. While stars follow bright and relatively brief lifespans, these clouds persist quietly in the background, holding their structure through eras that pass almost unnoticed, giving them a timeless quality that feels separate from the faster rhythms of the universe. Within a space cloud, the distribution of matter is never perfectly uniform, yet these variations emerge so gradually that the cloud maintains an overall sense of balance. Slight differences in density slowly influence how gas and dust drift, creating internal patterns that feel soft and organic rather than directed or forced. The cold interiors of space clouds allow them to act as natural archives of cosmic material, preserving atoms and molecules that have existed since earlier phases of galactic history. These particles drift without urgency, carrying with them the quiet legacy of long-gone stars that once shaped their composition. As space clouds move through regions of varying gravitational influence, their responses are subtle and delayed. Rather than shifting suddenly, the clouds stretch, compress, or curve gently over long periods, adapting slowly while retaining their fundamental calm. The immense size of space clouds means that different regions within a single cloud can experience slightly different conditions at the same time. Yet these differences coexist peacefully, with no sharp boundaries, allowing the cloud to function as a single, cohesive structure despite its internal diversity. Radiation entering a space cloud is gradually absorbed and scattered, creating deep interior regions where energy levels remain extremely low. In these quiet cores, conditions remain remarkably stable, allowing matter to exist in a state that feels almost suspended between motion and rest. Some space clouds experience faint pressure from the surrounding interstellar medium, which gently shapes their outer layers without disturbing their interiors. This interaction occurs slowly and continuously, giving the cloud a softly defined edge rather than a clear boundary. The dust within space clouds slowly changes over time as atoms settle onto grain surfaces or are released back into the gas phase. These changes happen at such a slow pace that the overall appearance and behavior of the cloud remains steady across immense spans of time. Space clouds can persist long after nearby star formation has ended, remaining as quiet remnants in regions that once hosted brighter activity. In this way, they serve as lingering presences, holding on to calm long after surrounding energy has faded. Even when viewed across cosmic distances, space clouds reflect a kind of gentle order shaped by universal laws that favour gradual change over sudden transformation. Their continued existence demonstrates how the universe often chooses patience, allowing vast structures to evolve slowly without interruption. Space clouds often continue to exist quietly, even as the regions around them change dramatically, with stars forming, aging and disappearing nearby. While these brighter events draw attention, the clouds themselves remain steady, absorbing only subtle influences and maintaining their calm presence through cycles of activity that pass around them rather than through them. Within the vast interior of a space cloud, distance itself becomes a defining feature, as particles may drift for thousands of years without encountering another. This immense separation allows motion to feel almost suspended, giving the cloud an internal stillness that is difficult to imagine from a human perspective. The slow accumulation and release of energy within space clouds occurs so gradually that it rarely disrupts their structure. Heat escapes in faint radiation over long periods, preventing build-up and allowing the cloud to remain cool, balanced and stable across cosmic timescales. Some space clouds subtly record the history of their environment through gentle variations in density and composition. These patterns form quietly, shaped by distant events whose effects arrive softened by time and distance, leaving behind impressions rather than disturbances. As space clouds drift through their galaxies, they encounter regions of slightly different pressure and temperature. Rather than reacting sharply, they adjust gradually, reshaping their outer layers while preserving the calm consistency of their inner regions. The immense scale of space clouds means that no single process defines their behaviour. Instead, countless small influences act together slowly, creating an environment where balance emerges naturally and change unfolds without direction or urgency. Even when space clouds are slowly drawn toward regions of future star formation, they spend most of their existence in a quiet preparatory state. This long period of calm allows material to settle naturally, guided by gentle forces that never rush their outcome. The matter within space clouds remains largely untouched by violent interactions, allowing atoms and molecules to exist in relative isolation for extraordinary lengths of time. This peaceful isolation gives the cloud an internal environment that feels deeply removed from energetic cosmic events. Space clouds demonstrate that much of the universe operates without spectacle, favouring slow continuity over dramatic transformation. Their existence highlights how vast systems can remain stable and gentle, shaping the cosmos quietly rather than forcefully. Even as the universe continues its gradual expansion, space clouds persist as calm structures within it, their internal rhythms unchanged by the larger motion of space itself. Within their quiet interiors, matter continues to drift, interact, and exist at its own unhurried pace, without signalling any final moment or conclusion. Space clouds often exist in regions where gravity from many distant objects overlaps gently, creating a smooth gravitational landscape rather than sharp pulls. In this environment, gas and dust move as if guided by a quiet consensus of forces, drifting slowly without being drawn urgently in any single direction. The immense distances inside space clouds mean that cause and effect are separated by long stretches of time. A subtle change in one region may take thousands or millions of years to influence another, allowing the cloud to absorb change gradually, without sudden reactions. Within space clouds, energy exchange happens at an almost imperceptible pace. Atoms release and absorb tiny amounts of energy through faint radiation, maintaining equilibrium so gently that the cloud's overall state remains calm and unaltered for vast periods. Some space clouds exist at the boundaries between different regions of a galaxy, where conditions shift slowly from one environment to another. These boundary clouds adapt quietly, blending characteristics from both regions without forming sharp divisions or turbulence. The slow drift of space clouds allows them to act as long-term stabilizers within galaxies, redistributing matter over time without concentrating it too quickly. This gradual redistribution helps prevent extremes, favoring balance over intensity. Inside space clouds, the absence of strong forces allows matter to follow paths determined mostly by chance and gentle influence. This randomness does not create chaos, but rather a soft unpredictability that unfolds peacefully over immense spans of time. Space clouds often remain unaffected by events occurring far away as distance weakens all influence. Explosions, radiation bursts, or stellar winds lose their urgency long before reaching the cloud, arriving only as faint reminders rather than disruptions. The internal rhythm of a space cloud is defined by slow repetition rather than progress. Gas drifts, settles, and drifts again, creating cycles that do not aim toward an endpoint, but simply continue as long as conditions allow. Some space clouds contain material that has never been part of a star, remaining in its original state since early galactic history. This untouched matter exists quietly, preserving conditions that have changed very little since the distant past. Even when observed with powerful instruments, space clouds often resist clear definition, appearing soft and diffuse rather than sharp or structured. This gentle ambiguity reflects their true nature, existing not as fixed objects, but as calm regions of slow, continuous change. Space clouds often move through the galaxy at speeds that feel almost motionless when measured on human timescales. Even when travelling thousands of kilometers per hour, the immense distances involved make their movement appear still, allowing them to remain in the same general regions of space for millions of years. Within the interiors of space clouds, matter experiences very little compression, allowing gas and dust to occupy vast volumes without crowding. This spaciousness contributes to the cloud's stable nature, as particles have ample room to drift without creating pressure or heat. The slow pace of change within space clouds allows them to preserve fragile structures that would not survive in more active environments. Molecules that would quickly break apart elsewhere can remain intact here, protected by the cloud's cold, diffuse conditions. Some space clouds exist near the edges of galaxies, where stellar density is low and external influence is minimal. In these quiet outskirts, clouds experience an even deeper sense of isolation, drifting through regions where few events disturb their calm. The interaction between gas and dust within space clouds creates a soft feedback system where small changes are absorbed and balanced rather than amplified. This self-regulating behavior helps maintain the cloud's long-term stability. Space clouds can subtly influence the motion of nearby material by gently redistributing mass over time. This influence is gradual and understated, shaping the surrounding environment without dramatic effects. The vast scale of space clouds allows them to act as quiet intermediaries between different regions of the galaxy. As they drift, they carry matter from one area to another slowly, smoothing differences rather than intensifying. Within space clouds, the absence of strong radiation allows temperatures to remain low and consistent. This thermal calm supports long-lasting conditions where matter remains steady rather than reactive. Some space clouds display faint internal motions caused by ancient events, such as distant stellar activity that passed long ago. These motions persist as gentle patterns rather than disruptions, preserved like echoes rather than impacts. Even after millions of years, space clouds often retain their essential character, remaining diffuse, cold, and calm. Their ability to persist without rushing toward transformation highlights how much of the universe exists in quiet continuity rather than constant change. Space clouds often exist in a state where no single direction defines their structure, allowing gas and dust to spread evenly across vast regions. This lack of orientation gives the cloud a feeling of openness, as though it is free from alignment or destination, simply occupying space without intention. Within a space cloud, the passage of time is marked not by events but by gradual shifts in balance. Pressure, temperature, and density change so slowly that the cloud's present state can feel nearly identical to its past, creating a sense of continuity that spans millions of years. The immense size of space clouds allows them to absorb disturbances gently, distributing any incoming energy across enormous volumes. This diffusion prevents sharp reactions, ensuring that even external influences fade into softness as they move through the cloud. Some space clouds contain regions where matter drifts in subtle spirals, guided by faint rotational motion inherited from the cloud's formation. These spirals unfold over long timescales, adding quiet complexity without disrupting the cloud's overall calm. The transparency of space clouds varies gradually, creating layers where light fades softly rather than disappearing suddenly. This gradual dimming contributes to the cloud's gentle presence, allowing it to exist without stark contrast against the surrounding universe. Inside space clouds, the absence of strong directional forces allows matter to follow paths shaped by minute influences. These paths do not converge quickly, resulting in a drifting pattern that feels unhurried and unconstrained. Space clouds often remain thermally insulated from their surroundings, maintaining stable internal temperatures even as nearby regions warm or cool. This insulation supports long-term calm, allowing the cloud's interior to remain consistent despite changes beyond its edges. The slow evolution of space clouds means that many exist longer than the stars they eventually help form. While stars pass through well-defined life cycles, clouds remain present before and after, quietly bridging different eras of cosmic activity. Some space clouds exhibit gentle gradients in composition, where heavier elements are slightly more concentrated in certain regions. These gradients develop slowly and remain stable, contributing to the cloud's subtle internal structure without creating imbalance. Even as galaxies interact, merge, or change shape, many space clouds continue their quiet existence with minimal disruption. Their ability to remain calm amid large-scale cosmic motion reflects the universe's preference for gradual adjustment over sudden change. Space clouds often exist in environments where temperature differences are so small that heat flows almost imperceptibly from one region to another. This gentle balance prevents internal stress, allowing the cloud to remain relaxed and stable for immense spans of time. Within a space cloud, the concept of direction becomes less meaningful, as particles drift freely without a clear sense of up, down, or forward. This absence of orientation contributes to the cloud's feeling of weightlessness and calm continuity. The gas in space clouds responds slowly to changes in pressure, spreading or compressing only over very long periods. This slow response acts like a natural buffer, ensuring that no sudden shifts disturb the cloud's internal equilibrium. Some space clouds exist in regions where starlight arrives only faintly, having travelled vast distances and lost much of its intensity. This softened light creates environments that remain dim and consistent, supporting long-lasting stillness. The internal motions of space clouds are often inherited from conditions present at their formation, preserved quietly over millions of years. These motions evolve gently, becoming smoother and more diffuse rather than energetic or chaotic. Space clouds can gradually exchange material with their surroundings, releasing small amounts of gas while gently acquiring more from nearby regions. This slow exchange allows the cloud to adapt without losing its essential character. The immense volume of space clouds allows them to dilute energetic influences naturally. Any incoming energy spreads across such a wide area that its effect becomes negligible, preserving the cloud's calm state. Within space clouds, matter often exists in a delicate balance between gas and solid phases, with atoms drifting freely while dust grains provide gentle anchors. This balance contributes to the cloud's long-term stability and quiet complexity. Some space clouds persist in regions where galactic activity is minimal, experiencing few disturbances over long stretches of time. In these quiet zones, clouds can remain nearly unchanged, serving as steady features in an otherwise evolving universe. The continued existence of space clouds reflects how the universe supports slow, steady processes alongside faster, more dramatic events. Their calm persistence shows that much of cosmic structure is shaped not by urgency, but by patience unfolding over time. Space clouds often exist in regions where the passage of energy is so faint that equilibrium becomes the natural state. Instead of fluctuating between extremes, these clouds maintain a steady internal condition, where temperature, motion and pressure remain quietly aligned for vast periods of time. Within a space cloud, the distances between individual atoms are so great that interaction becomes an occasional event rather than a constant condition. This separation allows matter to exist without friction or resistance, contributing to the cloud's deeply relaxed internal environment. The slow diffusion of gas inside space clouds allows denser regions to soften over time rather than collapse suddenly. This gradual redistribution ensures that balance is preserved, favoring stability over rapid transformation. Some space clouds are shaped subtly by the long-term influence of galactic tides, which stretch and compress them almost imperceptibly. These tidal effects work over millions of years, guiding the cloud's evolution without introducing urgency or disruption. The internal temperature of space clouds is often regulated by faint emissions of infrared radiation, which gently carry energy away. This slow cooling process prevents buildup and maintains the cloud's calm thermal state. Space clouds can exist in a quiet coexistence with nearby stars, absorbing radiation slowly and adjusting their structure over long timescales. Rather than reacting immediately, they respond with patience, reshaping themselves only as needed. The particles within space clouds follow paths determined by a combination of gravity, magnetic fields, and chance encounters. These influences blend smoothly, creating motion that feels organic and unforced rather than directed. Some space clouds experience long periods where no significant external forces act upon them at all. During these times, the cloud exists in near-perfect isolation, drifting gently and maintaining its internal balance without interruption. The vast size of space clouds allows them to smooth out irregularities naturally, as differences in density or motion spread out over enormous distances. This smoothing effect reinforces the cloud's overall sense of calm continuity. Even when space clouds eventually participate in larger cosmic processes, they spend the majority of their existence in a state of quiet readiness. This long, calm phase defines their character, allowing them to exist peacefully within the universe without pressure to change. Space clouds often exist in regions where the flow of matter is so gentle that their internal structure changes only through gradual rearrangement rather than movement. Gas and dust slowly shift positions over immense timescales, creating an environment where motion feels more like quiet adjustment than travel. Within space clouds, gravity rarely acts alone, instead blending softly with thermal pressure and magnetic influence. This balance prevents any single force from dominating, allowing the cloud to remain suspended in a long-lasting state of calm equilibrium. The vast emptiness inside space clouds allows particles to retain their individual paths for extraordinary lengths of time. Atoms may drift silently for centuries or longer before encountering another, reinforcing the sense that stillness defines these regions more than interaction. Some space clouds form in areas where earlier generations of stars once existed, inheriting material that has already been gently processed by cosmic time. This inherited matter carries a quiet history, present without needing to announce its past. The gradual fading of radiation within space clouds creates interiors that remain consistently dim, supporting conditions where change happens slowly and predictably. This steady environment allows the cloud to maintain its identity even as external conditions shift. Space clouds often expand or contract at rates so slow that their size appears unchanged across millions of years. These subtle changes reflect a natural tendency toward balance rather than growth or collapse. Within a space cloud, the absence of strong directional flow allows matter to distribute itself evenly, preventing build-up in any one region. This evenness contributes to the cloud's soft, diffuse appearance when observed from afar. The interaction between dust grains and gas inside space clouds creates a quiet cycle of absorption and release, where energy moves gently through the system. This cycle supports long-term stability rather than sudden transformation. Some space clouds drift through regions of space where gravitational influences cancel each other out, creating zones of exceptional calm. In these areas, clouds experience minimal distortion, allowing them to persist in near-perfect stillness. The enduring presence of space clouds shows how the universe allows vast structures to exist without urgency. Their long, quiet lifetimes reflect a cosmic rhythm where patience is not the exception, but the rule. Space clouds often exist in regions where the balance between expansion and contraction has settled into a long-lasting calm. Gas neither rushes outward nor collapses inward, instead remaining suspended in a quiet equilibrium that can endure for millions of years without noticeable change. Within space clouds, the faint glow of background radiation is often the only source of energy reaching their interiors. This weak, ancient light arrives softened by distance and time, contributing to an environment where nothing feels sharp or demanding. The immense scale of space clouds allows them to respond to influence with remarkable patience. Any external pressure or radiation is absorbed gradually, spreading through the cloud so slowly that its effects are softened into near stillness. Some space clouds drift through areas where the density of surrounding space is especially low, allowing them to maintain their structure without interference. In these regions, the cloud feels almost isolated, existing in a quiet separation from the rest of the galaxy. The particles within space clouds move according to gentle statistical patterns rather than directed flows. This randomness creates a calm, even distribution of motion that prevents sudden shifts or concentrated activity. Space clouds often contain regions where dust grains align slowly with weak magnetic fields, forming subtle internal order. This alignment happens gradually and quietly, adding structure without disturbing the cloud's overall calm. The thermal balance inside space clouds is maintained by slow exchanges of energy that prevent extremes. Heat is neither trapped nor released quickly, allowing temperatures to remain steady and supportive of long-term stability. Some space clouds pass through long periods where they experience no significant events at all. During these times, their existence is defined almost entirely by stillness, with only the faintest internal motion continuing quietly. The slow drift of matter within space clouds allows them to retain their identity even as individual particles come and go. This continuity gives the cloud a persistent presence that feels steady despite constant subtle change. Space clouds reflect one of the universe's most consistent patterns, where vast structures are shaped not by force or urgency but by time itself. Their quiet endurance shows how much of cosmic history unfolds gently, without requiring attention or resolution. Space clouds often exist in regions where the flow of time feels especially extended, not because time behaves differently, but because change unfolds so slowly that moments blend together. In these environments, the universe does not hurry forward, allowing structures to remain nearly unchanged across spans that far exceed human history. Within space clouds, matter is distributed so widely that pressure differences remain extremely small. This lack of imbalance prevents strong internal motion, allowing the cloud to remain relaxed and stable rather than driven toward rapid change. The cold temperatures inside space clouds allow atoms to remain in low energy states for long periods, reducing activity and supporting an environment of quiet persistence. This low energy condition helps maintain the cloud's gentle internal rhythm. Some space clouds occupy transitional regions between different galactic environments, gradually adapting to slow changes in radiation and density. These adaptations occur smoothly, without disruption, allowing the cloud to bridge conditions without losing stability. The vast distances inside space clouds allow light to lose intensity gradually rather than abruptly. As photons travel through layers of gas and dust, their energy is softened, contributing to the cloud's muted and peaceful presence. Space clouds often experience long-term balance between inward and outward forces, creating a steady internal state where neither compression nor expansion dominates. This balance allows the cloud to remain suspended comfortably over immense periods of time. Within space clouds, random motion does not lead to chaos, but to a soft averaging effect where extremes fade naturally. This gentle randomness supports calm rather than disorder, reinforcing the cloud's steady character. Some space clouds exist in regions where star formation has not yet begun, allowing them to remain undisturbed and unchanged. In these areas, the cloud's role is simply to exist, holding material quietly without pressure to transform. The interaction between gas, dust, and faint magnetic fields within space clouds unfolds gradually, shaping internal structure without sharp boundaries. This slow shaping preserves smooth transitions and avoids sudden shifts. Space clouds demonstrate that complexity in the universe does not require speed or intensity. Their layered structures and subtle behaviors emerge through patience, showing how intricate systems can form through calm, continuous processes rather than dramatic events. Space clouds often exist in parts of the galaxy where the gravitational pull from nearby stars is spread evenly, creating an environment where no single influence dominates. This balanced gravitational setting allows the cloud to drift steadily, maintaining its structure without being stretched or compressed too quickly. Within a space cloud, the extremely low density of matter means that even when particles move, they do so without resistance. This freedom of motion contributes to the cloud's relaxed internal state, where energy is never trapped and pressure rarely builds. The cold interiors of space clouds encourage atoms to release energy slowly through faint radiation, preventing sudden changes in temperature. This gradual cooling process supports the cloud's long-term stability and reinforces its calm internal environment. Some space clouds exist in regions where starlight arrives only after travelling through vast distances of interstellar space. By the time this light reaches the cloud, it has been softened and weakened, allowing the cloud to remain dim and undisturbed. The internal structure of space clouds evolves through slow redistribution rather than rapid movement. Gas and dust drift gently, allowing density differences to smooth out over time instead of forming sharp concentrations. Space clouds often contain material that has been part of the galaxy for billions of years, preserved in a state that has changed very little. This ancient matter exists quietly, offering a sense of continuity that connects different eras of cosmic history. Within space clouds, interactions between particles occur infrequently, giving each atom or molecule long periods of isolation. This separation reduces the chance of energetic reactions, maintaining the cloud's low activity state. Some space clouds experience long intervals where external forces are nearly absent. During these times, the cloud's internal processes proceed at their slowest pace, reinforcing a sense of deep cosmic stillness. The gentle exchange of energy between gas and dust inside space clouds helps prevent extremes. Heat absorbed by dust is released gradually, keeping the overall system in balance. Space clouds illustrate how large-scale cosmic structures can remain calm and persistent without requiring constant change. Their existence highlights the universe's ability to support quiet, enduring forms alongside more dynamic phenomena. Space clouds often occupy regions where the balance between motion and stillness has been settled for a very long time. Gas drifts gently without clear direction, creating an environment where movement exists but never demands attention or creates urgency. Within space clouds, the absence of strong heat sources allows temperatures to remain consistently low across vast distances. This uniform cold helps the cloud maintain internal harmony, preventing sudden shifts that could disturb its long-lasting calm. The enormous size of space clouds means that even gradual changes take immense time to spread from one region to another. A subtle variation in density or temperature may take thousands of years to influence the cloud as a whole, allowing change to remain soft and unhurried. Some space clouds reside in regions of the galaxy where stellar winds arrive greatly weakened. By the time these winds reach the cloud, their energy has faded, allowing the cloud to absorb their presence gently rather than react strongly. The gas inside space clouds often exists in a state where atoms move independently, rarely interacting. This isolation creates an internal environment where activity remains minimal and predictable, reinforcing the cloud's quiet persistence. Space clouds can slowly reshape themselves through gradual internal drift, smoothing rough edges and redistributing material over long timescales. This process happens without force, guided by natural tendencies toward balance rather than direction. Within space clouds, faint electromagnetic interactions occur quietly, influencing particle motion without creating turbulence. These interactions add subtle structure while preserving the cloud's overall stillness. Some space clouds exist in regions where the surrounding space is so sparse that external influence is nearly absent. In these environments, the cloud's evolution is governed almost entirely by its own internal balance. The slow loss of energy through faint radiation allows space clouds to remain stable rather than collapse or disperse quickly. This gentle release acts like a quiet pressure valve, maintaining equilibrium over immense spans of time. Space clouds show that in the universe not all structures are driven toward rapid outcomes. Many are allowed to exist in extended calm, changing slowly, quietly, and without the need for resolution. Space clouds often exist in regions where change unfolds so gradually that even the concept of progression becomes difficult to define. Within these vast expanses, gas and dust do not move toward goals or outcomes, but instead remain in a steady state of quiet adjustment. Forces act, but they do so gently, allowing the cloud to remain present without urgency, as though time itself has agreed to move more slowly here. Inside a space cloud, the idea of boundaries becomes softened, because there are no sharp edges separating the cloud from the surrounding space. Density fades gradually, particle by particle, creating transitions that feel smooth rather than defined. This gentle blending allows the cloud to exist as a region rather than an object, a calm zone where matter gathers without declaring an ending point. The internal temperature of space clouds remains remarkably stable over long periods, not because energy is absent, but because it is managed slowly and evenly. Heat escapes in faint radiation that carries energy away without disturbance, preventing build-up and allowing the cloud to maintain a peaceful thermal balance that resists sudden change. Space clouds often contain material that has travelled across vast regions of the galaxy before coming to rest within them. This material arrives gradually, slowed by distance and weakened forces, joining the cloud without disruption. Over time, the cloud becomes a quiet meeting place for matter from many origins, held together not by force, but by shared stillness. Within space clouds, motion follows no central rhythm, yet it never becomes chaotic. Instead, Countless small movements occur independently, averaging into a calm whole. This collective stillness emerges naturally as individual paths overlap without collision, creating an environment where randomness contributes to balance rather than disorder. Some space clouds exist in regions where gravitational influences from multiple directions cancel one another almost perfectly. In these rare environments, matter experiences an exceptional calm, drifting freely without being pulled strongly in any direction. This equilibrium allows the cloud to persist with minimal distortion, preserving its structure across immense spans of time. The gas inside space clouds can remain in a near-neutral state for millions of years, neither highly energized nor fully inert. This neutrality supports an environment where reactions occur only when conditions align gently, allowing chemistry to proceed without urgency or instability. Space clouds gradually absorb the faint background glow of the universe, a soft radiation left over from earlier cosmic eras. This ancient light arrives without intensity, blending into the cloud's internal energy without disturbing its calm. In this way, the cloud quietly connects the present universe to its distant past. Within space clouds, matter is allowed to rest in configurations that would be temporary elsewhere. Low pressure and extreme cold mean that structures remain intact simply because nothing forces them to change. This freedom from pressure creates a sense of deep patience embedded into the cloud's very existence. Space clouds remind us that much of the universe exists not in motion towards something else, but in steady presence. Their long lifetimes, gentle behavior, and resistance to urgency show how vast systems can remain calm without becoming static, changing slowly enough that stillness itself becomes their defining feature. Space clouds exist in a state where the universe appears to pause its urgency, allowing matter to occupy space without pressure to transform. Inside these immense regions, gas and dust are not driven by deadlines or stages, but by gentle coexistence. Forces remain present, yet subdued, guiding motion so subtly that stability becomes the natural condition rather than an achieved one. Within a space cloud, the distances between particles are so vast that interaction becomes an occasional event rather than a constant process. An atom may drift for centuries before encountering another, and when it does, the interaction is soft, unhurried, and brief. This separation allows the cloud to remain calm, free from frictional build-up, existing in a relaxed equilibrium that persists across cosmic time. The cold environment of space clouds supports a unique form of persistence, where structures are maintained not by strength, but by absence of disruption. With almost no heat to drive energetic reactions, matter remains settled into low-energy states, allowing the cloud to preserve its internal conditions with remarkable consistency over millions of years. Space clouds often gather material that has been slowly migrating through the galaxy, drawn in not by force, but by gentle alignment of motion and gravity. This accumulation happens quietly, with incoming particles blending into the cloud's existing structure without disturbance, contributing to its mass while preserving its overall calm. Inside space clouds, changes in density occur so gradually that the cloud can adapt without stress. Rather than forming sharp contrasts, variations spread out smoothly, allowing the cloud to maintain balance. This gradual redistribution ensures that no single region dominates, reinforcing the cloud's diffuse and tranquil nature. Some space clouds exist in regions where the background radiation of the universe is the primary source of energy. This ancient, faint glow permeates the cloud evenly, offering a soft connection to the early universe while remaining too gentle to alter the cloud's steady state. The result is an environment shaped as much by history as by present conditions. The immense scale of space clouds allows them to absorb disturbances without noticeable effect. When faint shock waves or distant radiation reach them, the energy is dispersed across enormous volumes, softening its impact until it becomes almost indistinguishable from the cloud's natural motion. This ability to diffuse influence protects the cloud's long-term stability. Within space clouds, gravity acts less like a command and more like a suggestion. Its pull is real but patient, encouraging particles to drift rather than forcing them together. This slow influence allows the cloud to remain extended and diffuse, resisting rapid collapse while still participating in the universe's broader structure. Space clouds often persist through multiple cycles of galactic change, existing before star formation begins and remaining long after nearby stars have faded. Their endurance makes them quiet witnesses to cosmic history, present through eras of activity without being consumed by it. The continued existence of space clouds shows that the universe supports forms of order built on patience rather than momentum. Their calm behavior demonstrates how complexity and stability can arise not from speed or intensity, but from time allowed to unfold without resistance. Space clouds exist in regions where the universe seems to favor continuity over change, allowing matter to remain suspended in a stable state for extraordinary lengths of time. Gas and dust do not rush toward transformation, but instead linger in a quiet balance, guided by forces that act patiently rather than decisively. This long-lasting equilibrium allows space clouds to exist as calm features of the cosmos, unchanged, while other structures evolve more quickly around them. Within a space cloud, motion unfolds at a pace that feels almost symbolic rather than physical. Individual particles follow long, gentle paths shaped by weak gravitational and magnetic influences, drifting without urgency or destination. This slow movement creates an environment where stillness is not the absence of motion, but the result of motion spread thinly across vast distances. The internal environment of a space cloud is shaped by extreme cold, which reduces activity and limits energetic reactions. At such low temperatures, atoms remain in low energy states, allowing the cloud to preserve its structure without constant adjustment. This thermal quiet supports a sense of deep stability that defines much of the cloud's existence. Space clouds often contain matter that has been traveling through interstellar space for millions or even billions of years. When this material becomes part of a cloud, it does not arrive suddenly, but blends gradually into the existing structure. Over time, the cloud becomes a quiet archive of galactic material, holding particles from many origins without distinction. The vast scale of space clouds allows them to absorb small disturbances without noticeable change. When faint radiation or distant shock waves pass through, the energy spreads across such enormous volumes that its effect becomes gentle and diffuse. This ability to soften influence helps preserve the cloud's calm internal conditions. Inside space clouds, chemical processes occur at extremely slow rates, governed by rare encounters between atoms and molecules. These reactions do not seek completion, but simply occur when conditions allow, contributing gradually to the cloud's complexity without disrupting its overall stillness. Space clouds often maintain soft internal gradients rather than sharp divisions. Density, temperature, and composition change gradually from one region to another, creating smooth transitions that reinforce the cloud's diffuse nature. This absence of boundaries allows the cloud to exist as a continuous environment rather than a defined object. The interaction between dust and gas within space clouds helps regulate energy gently. Dust grains absorb radiation and release it slowly, preventing heat from accumulating. This quiet exchange supports a stable thermal environment that allows the cloud to persist without dramatic fluctuation. Some space clouds occupy regions of space where external influence is minimal, far from intense radiation or strong gravitational forces. In these quiet zones, the cloud's evolution is governed almost entirely by its own internal balance, allowing it to remain unchanged for extended periods. Space clouds illustrate how the universe allows large structures to exist without urgency or resolution. Their long lifetimes and gentle behaviour show that not all cosmic systems are driven toward rapid outcomes. Many are permitted to exist in extended calm, changing slowly enough that their presence feels constant and reassuring. As this quiet journey through space, clouds continues to echo softly in your mind, there is nothing left to follow and nothing left to understand. These vast regions of gas and dust can remain exactly as they are, drifting patiently through the universe without needing observation or explanation. Their slow movements and gentle balances continue whether attention rests on them or not. You may notice your thoughts feeling lighter now, less defined, like faint traces of light diffusing through a cloud and gradually fading into the background. That softening is natural. Just as space clouds do not hurry toward outcomes, the mind does not need to reach clarity or closure. Everything important can remain unresolved, suspended comfortably in calm. Let your breathing remain easy and unforced, rising and falling without instruction. Let your body rest exactly where it is, supported by stillness rather than effort. You might imagine yourself floating within the open quiet, held gently by the same steady laws that allow space clouds to exist for millions of years without strain. Space clouds remind us that silence is not emptiness, and stillness is not absence. It is presence without demand, structure without pressure, and time without urgency. In that kind of presence, the mind is free to loosen, to drift, or to rest without direction. Thank you for spending this time with the Sleepy Scientist. Whenever the world feels loud or thoughts feel heavy, you're always welcome to return to this quiet science where curiosity moves slowly and calm is allowed to linger. For now, let the vastness remain where it is. Let the clouds continue their gentle drift, and let whatever comes next arrive in its own time without needing to be noticed at all. Good night.